Alrighty, so today we're going to have a quick look at calculating, or translating these functions up. So when we translate a sine function or a cosine function up, what it does is it moves that median value. So when we're sketching the image, we get a picture that looks like this with all of these spots that are in the middle. These are our key values. What happens when we do a vertical shift is we shift where this is in relation to the x-axis. So we can shift it up or down. You can have a play with it on Desmos if you want to believe me. But that's the basic idea. We're just going to shift this thing up. So the median value is just going to be 6 because as you can see, it's been translated up by 6. So let's say d value, if we have y equals a cos of bx plus d, you'll understand why later we're going to call it d. We've got one more transition to do. Then we get this d value on the end, and that's going to be our median. Now in this cos function, since our a value is still 1, because it's just cos, that means the amplitude is 1. And what we can do with this d value is work out our max and our min values. So our max value is always going to be the d value plus the a value, and the minimum value is just going to be d minus the a value. Because you either go up the amplitude or you go down the amplitude. From where? From d. Alrighty, now since b is equal to 1, then our period is just going to be 2 pi, our standard cosine period. So let's have a quick sketch. So what I like to do is, and since my median is 6 and my amplitude is 1, my maximum is going to be 6 plus 1, which is 7, and my minimum is going to be 6 minus 1, which is 5. So what I like to do is draw 3 horizontal lines, each representing these 3 values, so along my x-axis. So the first one is going to be my median. I'm going to do that in blue. It's going to be median at 6, so this is at 6. Then we're going to have a maximum at 7, and a minimum at 5. And so our peaks are going to hit the maximum line, our middles are going to hit the middle line, and our minimums are going to hit our minimum line. And setting up our axes, we've got 0 here, since our period is 2 pi, pi on 2, and 3 pi on 2. Alrighty, so those are my different intervals on my x-axis, and on my y-axis is what we've got up here. So the first point, because it's a cosine function, is going to be a max. It's going to start at a max, then it's going to go to the middle, then it's going to go to the bottom, and it's going to go to the middle, and then it's going to go back to the top. And there's my sketch complete. Just got to do a dot to dot now. And I only need to do it between 0 and 2 pi. Alrighty. So the same thing's going to happen with the tan function. It's not actually going to change our asymptotes because our asymptotes are infinitely long. It's only going to move where our zeros are. In this case, they're not really zeros. They're going to be below the x-axis, but they can still kind of be worked out. So in this case, our median, we don't have a maximum or a minimum. It's just going to be negative 10. And that's basically where our zeros are going to go. Let's draw up our axes. X and y, and the period, which is really important for the tan function, is just going to be pi, because remember, tan's base period is pi, cosine and sine are both 2 pi. We're doing it between 0 and 2 pi, and pi. And remember, tan starts at 0. It matches the sine function, and so it's going to repeat here and here and here. Those are all going to be zeros. Except that's not where our zeros are going to go, because our median is negative 10. So let's draw a horizontal line at negative 10. And all of these zeros have been moved down 10 units to fall upon this line. Now the asymptotes are still going to happen in between. So pi on 2 and 3 pi on 2. And we can draw our vertical asymptote lines to meet those. No, not there, yeah. And now we can just draw our function. So we're going to have it go up like this. Then it's going to come back through. And it's going to stop here, because that's what our domain said, was that it's between 0 and 2 pi. So even though it would continue up until the next asymptote, we're stopping the graph here. So there are my two sketches. There's my x and y axis all labeled, and we can go. And we could kind of estimate where we're going to get these x-intercepts, but at the moment we're not worried about solving for them just yet. Alrighty, see you in the next one. Goodbye.